Mathematics at Innate College, a YouTube channel for high school mathematics education. Mathematics 1C and Mathematics 3C. Swedish High School Education System. Functions. Hi, this is Babak. In this video I am going to solve the following problem for you. Let me read the problem for you first. Let g be a function such that for every non-zero real number x, g of x minus 3 times g of 1 over x equals to 3 times x minus 1. Determine g of 1, g of 1 over 2, and the rule of this function. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you do everything correctly, the answers that you will get are as follows. G of 1 equals to minus 1. G of 1 over 2 equals to minus 31 over 16. And finally, the rule of the function g of x would be 1 over 2 minus 3 over 8x minus 9 over 8x. Okay, now let me solve the problem for you first. So you know that you have some experience from the previous video. There, if you remember, we had this combination f of x and f of minus x. Okay? Now here we have g of x. Instead of g of minus x, I have g of 1 over x. Hopefully you understand what is going on now. Here my goal is to calculate g of 1. So this motivates me. You see that this relation is valid for all x's except 0. So if x is not 0, this will definitely give me a true statement. So I can just choose x equal to 1 because 1 is a non-zero real number. So this means that g of 1 minus 3 of g of 1 over 1 is equal to 3 times 1 minus 1. But then g of 1, still I don't know, but the good point is that 1 over 1 is exactly the same as 1, so it becomes minus 3g of 1, and the right hand side I have 3 times 1 minus 1, which is 2. But the good point is that these are the same. I have 1 of them, I take 3 of them. Okay, so how many of them will be left? Minus 2 of them. Minus 2 of g1 is equal to 2, but I am looking for this g1. So I divide everything by minus 2, and as is given in the problem, I get g of 1 is equal to minus 1. Okay. Now, for the second one, you have again enough experience here. So I want to calculate g of 1 over 2. So this motivates me to replace x with 1 over 2. Let us see what happens. So I will have g of 1 over 2. Instead of x, I am putting 1 over 2. So then it becomes minus 3g of 1 over 1 over 2. And on the right hand side, I will have 3 times 1 over 2 minus 1. But I can write this a little bit simpler. So what happens? This becomes g of 1 over 2, but 1 divided by 1 over 2, it becomes 1 divided by 1 over 2 becomes 2. So then it becomes minus 3g of 2. On the right hand side, I have this number to be 3 over 2 minus 1, so it becomes 1/2. So then it becomes 1/2. But that is a little bit unfortunate again, because these two are not the same numbers as the case for 1. So they might be different numbers, I don't know, so I cannot assume that they are the same. But the idea is that this is valid for all possible choices of x. Here I chose x to be 1/2, but I can also choose x to be 2, yes? So if I choose x to be 2, let us see what happens. Then this becomes g of 2 minus 3g of 1 over 2, because I am choosing x to be 2. On the right hand side, it becomes 3 times 2 minus 1. Then it becomes g of 2 minus, let me write it a little bit exactly below this, so it becomes g of 2, and then I will have minus 3 times g of 1 over 2, and on the right hand side I will have 5. Yes? Okay, but now you see that I can again consider this as in the previous problem. You have enough experience with this kind of problems now. I consider this as a system of two equations, one equation, second equation, and two unknowns. This is one unknown, and this is the other unknown. But my goal is to calculate this unknown. So it means that I need to get rid of this unknown, and that is easy here. I just multiply the second equation by 3. Then what happens? This becomes, I will get 3g of 2 minus 9g of 1 over 2. On the right hand side I will get 15. Now I will add these two, the left hand side of this to the left hand side of this. What is the good point here? Because you have here minus 3g of 2, here you have positive 3g of 2, they are gone. 1g of 1 over 2 is left here. Yes, and then minus 9g of 2 is also here. G of 1 over 2 is also left from here. On the right hand side I will have 15 plus 1 over 2. The left hand side I will have minus 8 g of 1 over 2. Yes, I have 1 g of 1 over 2, 9 of them I am taking it out, so minus 8 is left, and on the right hand side if I add these two numbers it becomes 31 over 2. Yes, so this becomes 31 over 2, and then I want to find g of 1 over 2, so I divide both sides by minus 8, and then it becomes minus 31 over 16. And that is the answer that I want to find. So if I divide 31 over 2 by 8, it becomes 31 over 16. So again, I would say that you might say that, okay, I find the general formula, and then of course using the general formula I can answer this one and that one. That's completely true. But the idea is that here what I need, if this is the only question, I want to teach you in this way, so that if this is all what you want, you really don't need to solve the most general problem and then go back to this special case. Because sometimes special cases, most of the time special cases are easier to solve than the general case. Of course, it's always possible to find the most general solution, and then using that general solution answer the particular solutions. Even though this is technically right, but it might make life harder for you. Of course, in this case that I have to calculate this one as well, so might be that's a good strategy. I would say to myself that, okay, let me solve this one, because at the end I have to solve for it, and then use this to solve these two. But it might be possible that in an exam you still cannot solve this one. But this doesn't mean that you cannot solve the particular cases, especially the first one. Even if you can solve this one, you can still get some points. So that's a good point. Even if you cannot solve the hardest problem here, you might be able to solve the simpler problem. Okay, now let us go to the last part of this problem. I'm supposed to show this. But the idea is clear, because this is valid for all non-zero numbers x. I would say that let x be a non-zero real number. Therefore, 1 over x is also a non-zero real number. Okay, now this equation is valid for all non-zero real numbers, including x and 1 over x. If I write this equation for x, then I will have g of x minus 3g of 1 over x equals to 3x minus 1. I can also write the same equation for 1 over x. It means that I replace x everywhere with 1 over x. So this becomes g of 1 over x. It becomes minus 3 of g of 1 over x, but 1 over x is the same as x. So this becomes minus 3g of x. On the right hand side I will have 3 over x minus 1, yes? So let me just explain. Instead of x I put 1 over x, but 3 times 1 over x is just 3 over x, and then I have minus 1, and this is exactly the expression that I have written here. But now the idea is clear as before, so I want to find g of x. My goal is to find this unknown. I need to get rid of this unknown. So the point is to multiply the second one by a 3. And then what I get, I will get this. Let me write them below each other. So let me just repeat this quickly. So this becomes g of x minus 3g of 1 over x. And then it is 3x minus 1. The other one becomes 3g of 1 over x minus 9g of x. On the right hand side I will have 9 over x minus 3. And then I add them. So what happens? This one and that one are positive and negative of each other. They cancel each other. And then one of them here minus 9 of them here. So it becomes minus 8 of them. On the right hand side I have minus 1 and minus 3. It becomes minus 4. I have to add these two as well, yes? So minus 3 and minus 1 is minus 4. Then I will have positive 3x, positive 9 over x. So positive 3x, positive 9 over x. But now I am looking for g of x, so I divide everything by minus 8. So it becomes g of x is equal to 1 over 2, because minus 4 divided by minus 8 is positive 1 over 2. And then I will have 3x over 8, and then finally minus 9 over 8x. And that is what I have. Let us check the answer. Yes, the answer is exactly the one that I have already provided. Okay. Of course, for example, if you want to double check, you can calculate g of 1. This is not part of the problem, but you can check yourself. G of 1 is 1 over 2 minus 3 over 8 minus 9 over 8. And now if I take the common denominator to be 8, this becomes 4 times minus 1 times 3 is 3, and 1 times 9 is that 1. So it becomes 4 minus 12 divided by 8, so it becomes how much? Minus 8 over 8, and that's exactly minus 1. So what I'm trying to say is that if you solve this part of the problem first, you don't need to solve this problem. You can just substitute and get the correct answer. As you see, g of 1 is minus 1. You can also test that g of 1 over 2 gives you exactly this number that we have already found. And even if you want to go further, you can really test this relation. Let us just do this exactly as the one that we did in the previous problem. So I want to test this idea that is this correct? Is my answer correct or not? So I would say that I start from the left hand side of this expression. Instead of g of x, I just put this expression that I got, which is 1 over 2 minus 3x over 8 minus 9 over 8x. Then I multiply minus 3 by g of 1 over x. So minus 3. G of 1 over x, what is the meaning? It means that I need to go to my function, and I replace x everywhere with 1 over x. So 1 over 2 remains untouched, but the next one becomes 3. X goes to the denominator. In the other one, the x is already in the denominator. If you make the inverse of it, x goes to the numerator. And then you need to simplify this expression. So this becomes equal to 1 over 2 minus 3x over 8 minus 9 over 8x minus 3 over 2. I multiply minus 3 inside, so it becomes 9 over 8x, then plus 27x over 8. Let us see how can I simplify that. So 1 over 2 minus 3 over 2 becomes minus 2 over 2, which is minus 1. Yes? And now look here, I have minus 3x over 8 and I have positive 27x over 8. It becomes 24x over 8, but 24x over 8 is just simply 3x. So it becomes plus 3x. And then you see that this one and this one are totally cancelled. So I get minus 1 plus 3x, but this is another name for 3x minus 1, and this is exactly the right-hand side. So what I have written here in this part is just a double check. You really don't need, if you trust your calculations, you really don't need this double check. But I just wanted to do this to show you that we have done everything correctly and what is the meaning behind this. Okay, you will find these notes, the link to these notes below this video in the descriptions. Until the next video, be safe and goodbye.